Hey students! Today we're going to talk about a topic from 3D geometry. That is, the difference between a prism and a pyramid. Now it's actually a pretty simple thing to cover, so this should be a fairly short video. Prisms and pyramids get grouped together because there are two different ways to take a two-dimensional shape and extend it along the z-axis into the third dimension. Now the trick is in which other shape you use to extend it. Let's take a look at an example. Here, I have two identical triangles that I've turned into 3D shapes. One of them is a prism, and one's a pyramid. But hopefully, from this angle, it's hard to tell which is which. That's because the exact same equilateral triangle has been used to create both of them. It's 5 centimeters on each side. Looking at them head-on, you can just see that triangle twice. But if I turn them, you can see that what makes these triangles three-dimensional is pretty different. One comes to a point, while the second comes to a second identical triangle on the other side. Now that's the difference between pyramids and prisms. A prism is any two-dimensional polygon that's extended to a second identical version of itself. This is a prism because I have a triangle, an identical triangle, and an extension along the z-axis where the two can meet each other. Drawing a straight line out from each corner gets me a prism. A pyramid is if I take this polygon, this triangle, and I bring all of its corners to a point. Now let's take a look at how this affects the net of the shape, which is what we call it when we unfold anything three-dimensional into its two-dimensional blueprint. Now this is the net for my prism. Because a prism is going to connect one polygon to another identical version of itself, each corner of it will be connected by a straight line. This corner to this through a straight line, this corner to this through a straight line, and when I fold it up, the tops to one another also by this straight line. Now, because every corner is attached in this way, all these straight lines actually result in every side that isn't my starting shape turning into a rectangle. So, a prism is two identical polygons connected to one another via rectangles. Now, looking at the pyramid net, we can see that coming to a point really does change the shape that we use to attach all of these things. Eventually, every corner of this triangle is going to need to meet somewhere else. That means that that straight line going from the corner to where it meets is going to result in every side of this polygon eventually coming to a triangle, coming to that point. So every other face of this polygon, aside from my starting shape, has to be a triangle. A pyramid's net is always your starting shape and a bunch of triangles, however many triangles as that starting shape has sides. So a pyramid is one polygon which eventually comes to a point through a bunch of triangular faces. Now my example objects are both based off of a triangle, and that means I call these a triangular pyramid, a pyramid from a triangle, and a triangular prism, a prism from a triangle. When we're naming prisms and pyramids, we just need to find the polygon that they're based off of and give them that name. Let's take this to the diagrams for a quick example of a couple of others. Here I've drawn nets for two different objects. Looking at this net right here, I can see a set of rectangles which connects two pentagons together. Now I know two things from this. The first is that my base shape is a pentagon. The second is that it extends through rectangles. Because of this, I know its name. Since it's based on a pentagon, I say the object is going to be pentagonal. And because it extends through rectangles, I know any 3D object that extends through rectangles in this way is called a prism. So this will be called a pentagonal prism. Now for my second shape, please excuse that it's a little bit crudely drawn. It's a hexagon, a six-sided shape, six-sided polygon, which extends through a bunch of triangles. Just like last time, I know two things from this. The first thing is that the base shape is a hexagon, and the second is that the thing that makes it 3D is going to be a triangle. Because it's based on a hexagon, I call it hexagonal. And because it extends through triangles, I know that if I fold this up, it will eventually create a pyramid. It will come to a point. So, it's a pyramid. This is a hexagonal pyramid. Now I can do this with any shape. If my base is an octagon, I can look if it comes out through rectangles or triangles, and name it either an octagonal prism or an octagonal pyramid. If it's a nonagon, a nine-sided polygon, well, it's a nonagonal prism or nonagonal pyramid. If I know the shape, I've got my name. Now, cubes do mess up this pattern a little bit. Usually, if we have a rectangle extended by other rectangles, we would call that a rectangular prism. But just like quadrilaterals, when we have something with all equal sides, a square, it messes up our naming conventions a little bit. So, if a square, a type of rectangle, is connected to another square by other squares, if every face of this 3D object is the same, we call that a cube, not a rectangular prism. Even though we would be accurate in calling it a rectangular prism if we wanted to. If we have two equal squares, which are also attached to one another by rectangles, again, we could call it a rectangular prism. That's fine. But another term for this, because it's kind of like a cube, is a cuboid. So, when we have rectangles connected by other rectangles, every one of these is a prism, but we would call them rectangular prisms if they were uneven all around, cuboids, or cubes. And that's it.
And there you have it. If you can name a polygon, you can name a 3D object. All you need to do is recognize the shape of the base and notice whether it extends through triangles or through rectangles. Triangles will always give you a pyramid. Rectangles, going back to the same shape again, will give you a prism. Have fun building and naming prisms and pyramids, guys. Peace.